Okay, so we are going to be able to finish up the current lesson today. I don't see any issues with the truth tables. We'll go ahead and review in just a second, just a few items. In a couple of days, you're going to have your next quiz on Thursday the 18th, and that will cover information from the homework we turned in yesterday, introduction to sets, so union, intersection, complements, things like that, and Venn diagrams. The exam is coming up next Thursday on the 25th, so we want to be looking ahead to that. It will definitely have that first section, the same material from the quiz, our current lesson right here over propositions and truth tables, and more than likely, I believe we should be able to finish implication and equivalence by next week, even though next week is going to be a short week. So don't forget, Monday you don't have school. I still have to go to work, so, feel for me. Hello. I will survive. Yes, I will. Caitlin. Okay. So, let's see. We talked about the quiz, the test. Is there anybody out there who still needs the homework key from yesterday? Okay, Alejandra, would you give that to Zoe when you're done? Anybody else? Okay. The only other thing, I do apologize about this morning if anybody had plans on coming in. Hopefully my text made it and nobody showed up to see that I wasn't here. But I, at the last minute, was told about this meeting. I really tried to get out of it, but it was one of those things where they said, you have to be here. So I was like, okay. And I know tomorrow was the deadline by 8:05 for last week's test if you want to retake it. So because that was out of my hands, I'm going to go ahead and just extend it one day. So you still have a couple of days, Thursday morning by 8:05. If you want to come in, ask me questions, we'll talk about that. That's all I have, unless anybody has anything they want to talk about, questions? Okay, then let's see what we're doing here. We've been talking about truth tables, starting with propositions, and these are the little statements that we're looking at. Typically we call them P and Q, possibly R, and we've been relating these back to what we talked about with sets. So let me go ahead and do this very quickly, just make it look a little better. It's not going to be perfect, but that's okay. It'll look better if I, just it looks sketchy to you. And I know it's the truth because Eli's not lying. Lying. Yes, yes, it's happening. Okay. All right, so just a quick little box here. So we've been talking about these, propositions, and it's just a statement of fact. It's never a question. It's never going to be a command. And we've been looking at all these different ideas. We brought up some new terminology. The negation, which we use if we have a proposition P, then the negation is that sideways L we go ahead and put before it. There's also that little curving line, okay, tilde we can go ahead and use for negation. So if I have a truth table and I have P and I'm wanting to show not P, well, we're going to have true and false. So negating a truth would be false and negating a false would be true. Now for this one, I know that I'm only going to have 2 rows. Remember, when you're trying to figure out how many rows your truth table is going to have, you always start with base 2, and then you raise it to the power of the number of propositions that you have. So if I only have, 1 proposition, I'm just dealing with P, well, 2 to the first is 2. But if I go ahead and start comparing propositions P and Q, okay, so let me go ahead and take that off here. Take that off. P and Q, get out of there. So now I have 2 propositions, so base 2 to the power 2 tells me I should have 4 rows in my truth table. Okay. And then if I have P, Q, and R, as they're typically called, I'll have 8. And then, they're going to grow exponentially. Okay. So union and intersection. What was the new vocabulary word for intersection? Conjunction. Okay. So we have a conjunction. So up till now, we've been saying, P intersecting Q. We've now got this new notation. Okay. An upside down V, which means the same thing. But now as far as the truth table goes, let's go ahead and say P and Q. So we're going to have true, true, false, false. And when you're setting these up, the first half of the rows are always going to be true, the second half is going to be false, and then they start to alternate. Okay, so for Q, this would be true, false, true, false. Okay, so what does this mean in terms of the truth table? Like, how am I going to get a truth out of this? What has to happen? Okay, so I heard they both and I heard one. They both. For an intersection, they both have to be true to get a true outcome. So true, true, that's a true. If only one of them is true, then the outcome is false. Same thing here, false, true is a false. And if they're both false, well, that's going to be a false itself, right? Okay. So that's a conjunction. That's an intersection. That's joined by the word and. Okay. Let's do another one. What was the word for union now? Disjunction. Okay. So P. All right. We got Q. So we've been seeing it like this, if it will allow me to write. There we go. P union Q, or we also have P with the union Q as the capital V. Now, there is a difference here. There's two types of the union. Does anybody remember what I'm referring to? The inclusive and the exclusive. So this one here, if I don't have that bar, what's that? That's the inclusive. Okay, so this one, the way it goes, it could be one or the other, or, but, whoa, interesting, or both. One or the other or both. So let's set up the truth table. True, true, false, false. True, false, true, false. And the reason we do that is because we want to find every possible outcome for the two propositions. We have one outcome where they're both true, one where the first is true, the second is true, and then both false. Okay? We're just looking for everything that's possible. All right, so how does this work? What would the true, true give me? That's a true. At least one has got to be true, so that's a true. What about true, false? That's a true. False, true? That's a true. False, false. This is the only one that's false for the inclusive union. Okay. Now the other one, if I go ahead and change it, if I put a bar here, then it's no longer inclusive, it's exclusive. So this is one or the other, but not both. Not both. So let me go ahead and erase this column right here. Okay. So what about a true, true? That's a false. Okay, so one or the other can be true, but not both if it's exclusive, if it's got that bar. So this is a false. True, false? True. False, true? And then if they're both false, false. Okay. So this is what we were talking again through yesterday. We went ahead and did some extra problems after it, and I want to say we got to the last charts. Is that right? Did we start this one, or I think we stopped, didn't we? We stopped. Okay. Okay. So we actually don't have a whole lot left. We'll go ahead and wrap this up, and then you should have some time in class to go ahead and begin your assignment. Okay. So let's see here. Create a truth table for the negation of P and Q or R. All right, and you remember what I said yesterday, these guys build upon each other. You want a column for each of your individual propositions. Then you want to go ahead and start to expand on it. We want one column for the quantity, then we want the negation of that quantity, and then we want one for the union. Okay, so let me go ahead and kind of revisit something I also said at the beginning. Why does this one have 8 rows, but the other ones I was looking at just had 4? Okay, because again, it's base 2, but what would the power be? We've got 3 propositions this time, P, Q, and R. So there's my 8. Okay, so that always tells you how big your truth table ought to be. All right. So why don't we go ahead and do this one at a time? And I like to go ahead, when I'm doing these columns, kind of draw arcs, just so I can visually see, which ones I need to be looking at. Because for this fourth column here, I don't need to worry about the third one. So let's take 30 seconds. Okay. Let's see if we can fill in that table based on what we've been talking about. So we want the intersection of P and Q. R won't even come in until the very last one. Okay, so these first two columns, and you may not be done, and that's okay. The intersection, what was this again? It can only be a true statement if they are both true. Okay, so true, 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 true. Then what should the next one be? False, 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 and false. So only the top two rows are true. How many people got that? Okay, good, 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 good. So now all I want to do is negate the intersection that we just got. Well, that just changes it from true to false and vice versa. So now the first two rows should be what? False, false, and then the rest of these are true, 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 true. There we go. True, 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 true. Okay. All right. And now I want to go ahead and take a look at that column, union R. So R finally comes into it. Now, is this the inclusive or exclusive? This is the inclusive. If it has no bar, it's inclusive. So this one or the other, or both. Yes, as long as at least one is true. So again, you can draw an arc. If I'm doing something like this, I like to go ahead and highlight the rows that I'm looking at, because again, I've already used the other columns. I don't need to look at anything else. So let's see here. I want true, false. That's a true. False, false. False, true, true. False, true. True, true. False, true. True, true. False, true. Okay. Now, one of the things we're going to be talking about in the very next lesson, we're going to be able to identify if our statements are accurate or if they're not. If your final statement, the one that you're trying to show, if you get nothing but truths all the way down, we call that a tautology. And I'm just kind of showing you now because later on it'll come up again and hopefully you'll remember it. But that means your statement is true. If you get nothing but all false, that means it's a contradiction. Okay. In this case here, could I say it's a tautology? Can I say that this statement is true? No. This one false kind of ruins the whole thing. Okay. Hey. Okay. Well, let's see what else we got here. So now we're actually given statements for the propositions. So x is a multiple of 5 less than 20. Q says x is a multiple of 3 less than 20. R, x is an even number less than 20. Okay, so those are my three propositions. And write in words and create a truth table for P or, okay, the intersection of Q and not R. Okay. So I'll show you what I wrote in just a second. See if you can come up with some kind of statement relating those three propositions. Okay. So we're wanting P or the quantity intersection of Q and not R. And remember, there's always going to be different ways to make a statement. Mine is by no means the only way. I'll just go ahead and show you in a second what I got. Because this is something they may ask you to do on the paper exams. You may fill out a truth table, talk about the validity of it. Is it tautology? Did you get all truths? Is it a contradiction? Did you get all falses? and they may even have you verbalize what statement it is you're trying to show. Okay, does anybody want to go ahead and tell me what they wrote? Okay, Spencer, what you got?
X multiple of 5 less than 20, or an even multiple of 3 less than 20.
Or an even multiple of 3 less than 20?
Yes.
Okay, what do you guys think? Okay. All right. So we got the even. Did we get the multiple of 3? Now remember what were we doing to R? We're also negating it, right? Okay. Okay. But that's a good way of putting it. Michelle, do you want to share yours? Okay. You know, it does start to get a little redundant, but I might go ahead and do it just to be on the safe side. I mean, the reader hopefully knows what it is you're talking about, but, you know, especially when it comes to the paper exams, you just never know who's going to be grading your test. So my thought is always put as much as you possibly can in situations, because I don't know, for me that's kind of a complicated question to ask. I would probably go ahead and do it. Okay. Honestly, I don't even remember what I put. Let's see what I put. Let's see. I put x is a multiple of 5 less than 20, or a multiple of 3 less than 20, and not an even number less than 20. So I did go ahead and write that every time. Okay. But you probably could shorten it down to where you don't have to put less than 20 and still know what it is you're talking about. Okay. So x is a multiple of 5, maybe just the first one, less than 20, and a multiple of 3, but not an even number less than 20. Maybe something along those lines. Okay. What do you guys think? Good? Anybody else want to share their sentence? Hey, Eli, go for it.
X is a multiple of 5 less than 20, or a multiple of 3 that's odd and less than 20. Or an odd multiple of 3 that's less than 20.
Or a multiple of 3 that's odd
Or
and
an
what?
odd multiple of 3 that's less than 20.
Okay, yes. An odd multiple of 3 less than 20, because that also takes care of the even. Yes. I like that. That's really good. Okay, excellent. Okay, Emily, you want to share yours? Or were you just... Oh, okay, you were just stretching. Okay. Okay, good. Very good. Good. All right. Well, I think... Is that my last one? Nope, we got a couple of them. Okay. Yay! Okay. So here is the truth table for what we were just looking at. So again, we got 8 rows, 3 propositions. We have a not R. We have an intersection of Q and not R. Okay. And then we have the entire thing. Again, it's going to build upon itself, all the base elements there. Does anybody want to come on up and show me how the truth table would fill in? Okay, Eli. Okay, so the negation is always going to be pretty easy. How does that relate back to sets? That's the what? That's the complement, yes. Everything in the universe, but not in that given set. Perfect. Okay.
Can we do the next one as well?
Well, let's see. Did you want to keep going, or did you want to go ahead and get somebody else up here?
Everything classes. Somebody else wants to come up here? I volunteer to serve it to them.
Okay.
Great. Okay, so that's the intersection. It's one or the other.
One or the other, but not both.
So this one, they're all true, right? Since one over the other.
Now remember, we're wanting to look at specifically Q and not R. So let's see, true, false.
So that'd be false.
That'd be false. Okay.
False. True.
That one's true. False, false. False, true. False. What about a true, false? Okay. True, true. That one's true.
That's false.
False. False. Yes. The intersection is is both, but not just one.
So, and then we do the union. This one's inclusive, so it can be one or the other.
Okay, so now we're going to go ahead and take this one with P. So we're only comparing the first column to this fifth column.
Yes, this one's one or the other, if not both. So like this one, so it's true, false, so it'd be true.
Okay.
This next one's true, true, so it'd be true.
Okay.
This one would be true, false, so it's true. Then false, true is true.
What?
Wait, no, sorry.
Well, true, false is still true. Yes.
And then
Okay.
false, false is false. And then false, true is true. False, false is false. And then last is also false.
And there we go. That's it. That's exactly right. Yay. Are we starting to get the idea of truth tables? Is anybody confused by their behavior? Okay. All right, here's our last example. Write a truth table for the intersection of P and Q or the intersection of not P and not Q. Then draw a Venn diagram to represent the set equivalent of the logic. Okay, do we want to try this one on our own and then maybe come back together? Or do you just want to work it together? What would you guys like to do? You still want to go ahead and work together? Okay. Well, if we'll work together, how about we go ahead and get a little train going? So, Eli, who would you like to see come up and complete this third column? P and Q. Spencer. So we're going to get 1, 2, 3, 4, 5 people. Okay, so Spencer will then choose, and then that person will choose, and we'll just keep going. So, and, okay, true, false, false, false. Both have to be true. That is exactly right. Okay. Samir, he is going to have not P. Okay, so the negations will go quickly. False, false. There you go. Perfect. All right. So now we got not Q. Okay, so all we want to do is negate this column right here. Very good. True is false. And a false would be, that's it. Oh. Now the last Q was false, and we're wanting to negate that. That won't be true. Oh yeah, just use the other end of the pen. There you go. Perfect. Okay. Yes. Louise has our first quantity, not P and not Q. Well, really second quantity, I should say. So again, with an intersection, both must be true. If only one is true, we can't accept it. So now we're wanting to take the intersection of these two columns. So I only want to focus on these. So they both have to be true in order to be true. So do I have any truths there? So that one is false. False true is false. True false is false. But a true true is true, yes. Okay. Now I want to take the inclusive union with the two quantities we have. Creamy. All right.
Can you explain it to me?
Okay, so we're going to focus on these two columns. Let me go ahead and highlight these for you. Okay. So I've still got the highlighter. So we want P and Q. We want this column here. And not P and not Q. We want this column here. So for these two, we want to take, is that the inclusive or exclusive union? That's the inclusive. Okay. So what does that mean? It either means one or the other or both, or one or the other but not both. Or both. Yes, there we go. So as long as we have at least one true, you can get a true statement. So true, false is true. So what would we say about false, false? Yes, that's correct. What about a false, false? Another false. What about a false true? That's true, yes. Perfect. Now again, I'm not holding you to these words right now, but I'm just going to go ahead and throw them out there. If I'd gotten all truths, this would have been known as a what? A tautology. Okay? A tautology. And it would have been an accurate statement. If we'd gotten nothing but falses, that would have been a contradiction. Okay. Very good. The only thing left is to go ahead and draw a Venn diagram to represent what we have here. Okay, so I'll tell you what. Take about 30 seconds, 40 seconds. Draw what you believe it is. And then we'll all come back together and we'll take a look. So kind of think about it this way. In terms of sets, I want the union of their intersection and their complements. I want to combine what they share and what they don't, what's outside them. Yep. Now, for one like this, if you're having a little bit of trouble, what could help? Yeah, draw them individually. Like this first one right here. P and Q. I got my two circles. Well, the intersection has to be this middle region right here. Okay. Then we can do the exact same thing for not P intersecting not Q. Okay. Not P intersecting not Q. Okay. But now again, I'm going to go ahead and stop there. Let's see if maybe that kind of helps somebody get it to the end. And while you guys are doing that, let me go ahead and pass out your assignments. Logic and truth tables. Okay. And I'm thinking probably Thursday. You think that'd be enough? Unless you guys just want to try and turn it in tomorrow? Yes. Yes. Where's that key? Zoe, do you still have the key? Okay. Thank you so much. There you go. Okay. So let's see. Did I give you? I did give you the home. Okay. There you go. There you go. All right. So let's go ahead and make this homework due on Thursday. All right, now I'll go ahead and put the rest of these over here. This is Tuesday. Okay. All right, last problem of the day. Would anybody like to come on up and show me where they believe it is? Let's get somebody who hasn't been up today. In fact, who was the last person to come up? Karime? Karime, who would you like? Oh, no hesitation. Gabby. Okay, here we go. Uh-huh. I don't know. That seems pretty shady to me. Shady, good. It's a shit. Not cool. What? I wasn't saying anything bad. I was making a joke off being shady.
Yeah. Oh, you don't get it?
Like someone's shady. Like you're doing something wrong. Maybe I should just stop talking. Okay. Okay. I can tell exactly what you're doing. Yeah, that's perfect. There we go. So she went ahead and shaded in everything outside the circles and their intersection. That is absolutely right. Did anybody want me to kind of elaborate on this other one that I drew here? The intersection of not P and not Q? No? Yes? Okay. Well, let me go ahead and do this in different colors because that'll probably help to distinguish it. So, ooh, yeah, there we go. Took me a second. Okay. So everything not P, the complement, would be everything outside of P, right? So this guy right here. So that represents the not P, and let's go ahead and say purple for the other one. Now I want everything not Q. Okay. Now, putting those together, where's the only place that I have an overlap? Yeah, it's only outside the circles. So I want to take this whole area here. Okay, right there. And then I want to combine it with this. Now remember, we're not looking for the intersection of these two. We're looking for the union. So I want to combine them. Yes, the marriage of the two. That's absolutely right. Caitlin, does that help? Okay, yes. Well, it does. It's mirroring what we're doing because it follows the same ideas. You remember, like, we're always able to reconnect this back to what we've been talking about with sets. This is just an extension of that.
So, like, how do you like treat people like in relationship with your result, like your Venn diagram?
Okay. So how are we going to connect the truth table to my Venn diagram?
I got that.
Okay. Well, we can go ahead and come on now. Regardless of what the propositions are, it's probably going to make a lot more sense once we start talking about the validity of these statements, because I've kind of started bringing up the vocabulary sooner than normal, the tautology, the contradiction, and there, hopefully, you'll probably see a more direct connection. At this point, I don't know the best way to answer that question. So let's see what happens in the next lesson, and let's see if maybe I can help you with that. Okay. All right. Yes.
No, I was gonna.
Oh, you're going to turn on the light? Oh, we're not done yet. Okay. Because now you got your homework. Is there one question on the homework you want to take a look at? Remember, when's this due? Thursday. It's the same day you're going to take your quiz. This is not going to be on the quiz. It's just that previous homework's content. Okay. Number what? 6. Okay. Do all the problems? Oh, all of number 6? Well, I'll tell you, we could probably work it together. Okay. Because is there any part past this right here? Nope, it goes right to number 7. Okay. Well, I mean, if you want me to go ahead and just turn you guys loose.
I like that idea.
You like that idea better than my working a problem? Okay, well, let's vote. Let's vote. How many people want me to go ahead and work a problem? Okay. How many people would like me to just go ahead and turn you loose and let you work together? Okay, so Eli, if you just want to go ahead and work on your assignment, you are free to do so. Okay, so let's see. Let P, Q, and R be the statements. X is a multiple of 5, X is a factor of 45, and Rx is a square number. Write a sentence in words for this statement. Okay, so P or R, that's my quantity, and not Q. Okay, so let's see here. So we want to take the union of X is a multiple of 5, X is a square number, and not Q. X is not a factor of 45. Okay. So I already kind of have an idea of how I would probably say it. What would you guys like me to put down? Oh, Eli, yes.
square number that's a multiple of 5 and is a factor of 45.
Okay, so say it again. A
A square number that's a multiple of 5 and is not a factor of 45.
a square number. Yep. There we go. That is, say again, sir. A multiple of 5.
5 and is not a factor of 45.
A multiple of 5 and not a factor of 45.
Yeah, it's not a factor.
Whoa. Okay, so he says a square. I just realized I put numer. Hashtag.
Like that.
Well, I know what the hashtag is. I'm just wondering how that applies here.
Well, a square number. That's,
Oh yeah, but I'd accidentally just put number instead of number.
well, yeah.
Yep.
We're
Fair
on the
enough.
same
There we
page.
go.
That's the
We're
problem.
on the same page now. Okay, here we go. So a square number that is a multiple of 5 and not a factor of 45. What do you guys think? Okay. I'd say that's great. Would anybody have said it differently? No? We all probably would have gotten along the same lines? Okay. Create a Venn diagram that represents the truth sets of these right here. So here's the thing. You're creating a Venn diagram. You want to go ahead and put these values in the Venn diagram. So we need to know what their sets are made of. Okay? X is a multiple of 5. Let me get out my assignment here, because I'm pretty sure we put this in here. Oh, no. We actually don't need the sets. We just go ahead and shade the appropriate region. Okay. Now, let's see if I can make this big enough. There we go. And let's say that this right here is P, this is Q, this is R. Okay. So I want a Venn diagram that represents the truth set. Okay. So let's see, we want the union of P and R, but we want that to intersect with not Q. So let me give you a minute to think about that one. Not Q, that means the complement. So I want everything outside of Q, inside the universe. And I want to take the intersection of that with the union of P and R. Again, another good example of doing what? Taking it, yeah, one part at a time. Okay. So this is P, Q, R. Okay, so this would be P or R. This would be not Q. Okay. So P or R. What am I going to shade in? All of P and all of R. Okay. And then not Q, well, that's its complement. Everything inside the universe, but not inside Q. Okay. And then what am I wanting to do, bless you, with the two of them? I want to go ahead and take the intersection. So if I were to go ahead and take one and place it on the other, what are the only regions that are going to be the same? Okay. Someone want to come show me? Okay, Samir? Well, Samir, didn't you come up today?
Yeah.
Yeah. Who's someone who did not come up today? Who was the last one to come up? Gabby. Who do you want, Gabby? Who?
No.
Yeah, I think
I
Abby
remember
really
that I
is
did
itching
go
to
up.
go.
All right. Okay. There you go, ma'am. Okay, so if I were to place one over on the other, where would they intersect? What do you guys think? That is perfect. That is exactly right. There you go. Good job. Good job. Remember, if it feels like it's going to be a pretty tough Venn diagram, take it one part at a time. Okay, step by step. Okay. And let's go ahead and finish this up. So now I want the inclusive union. So this means one or the other or both. So true, true. True, false. True, true. True, false. False, true. False, false. False, true. False, false. Okay, would everybody agree? Now, the negation is always the easiest column to fill in. I'm just going to switch every answer I see here. So it goes true, true. So I'm going to go false, false. Then it goes false, false. So true, true. And you'll notice that pattern just continues. So two more falses and two more trues. I want the truth. You can't handle the truth. You guys know that movie, right?
Yeah.
There you go.
What movie?
Jerry Maguire. Really?
Jerry Maguire?
Yeah, with Tom Cruise.
See, I've never seen that movie, but I know that quote. I've never seen
Yeah, it's become part of pop culture. Or no. No, that's a few good men.
Yeah.
I was thinking of a completely different Tom Cruise movie. Yeah.
I'm thinking of Top Gun.
No. Top Gun, I know. No, it was A Few Good Men because it was Jack Nicholson who was. You're damn right. I ordered the Code Red on Santiago. I didn't say the whole thing because that wouldn't have been appropriate. Okay, again, let's go to math. Okay, so let's see here. Now I've got my quantity, I've got not Q, and I want the intersection. So I'm only looking at these guys here. So this one, what's the intersection? At least one, both have to be true. What's the relationship? For intersection, both have to be true. So true, false. True, false. False. True, true. True. True, true. True, false. False, false. True, true. And false, true. Okay, there we go. Yes. Oh, that means the actual set. Like what number are you on? Number 3. Okay. So find the truth sets. So like, for example, x is a multiple of 3 between 1 and 20. So then you would actually write out the elements. So that would be, 3, 6, and then you would keep going until 18. Okay. All right, there we go. Okay, so I've got 207. As always, you guys did a great job. I appreciate it. If you can go ahead and put your calculators back up front. Yes, ma'am.
We just do it like that, or would we actually write it out?
For that one, I would probably write it out because there you're wanting to say 4 is not less than 6. You're just wanting to negate it. Does that make sense?